Today we're learning lesson 5-3, medians and altitudes. Our learning targets are students will understand the medians of a triangle are concurrent at its centroid. So you want to think medians and centroid. The other thing that you will understand is that lines containing the altitudes of a triangle are concurrent at its orthocenter. And our vocabulary for today is the altitude of a triangle, altura de un triángulo, centroid of a triangle, baricentro de un triángulo, median of a triangle, mediana de un triángulo, and orthocenter of a triangle, orthocentro de un triángulo. Example 1. Identify special segments in triangles. An altitude is a perpendicular segment from a vertex of a triangle to the line containing the side opposite the vertex. And we will see that in our next example, what an altitude looks like. A median of a triangle is a segment that has endpoints at a vertex and the midpoint of the side opposite the vertex. So what are the altitude and median that are shown in triangle ADC? All right, so the altitude is a perpendicular segment, so that's actually going to be this line here. So the altitude is line AE. And the median is the midpoint to a vertex, so that's line DB. So now do the try it problem. What are the altitude and median that are shown in triangle ABC? And I'll pause the video for you to find out. All right, for the try it, did you get that the median was DB and the altitude was CE? For example 2, find the length of a median. What is the length of JN in the figure? So I'm going to highlight that so you can see it, J to N. And they're telling us that the medians of JKL are JN, KP, and LM. Point Q is the point of concurrency of the medians. So we can see that right here in the middle, that's point Q. And point Q is the centroid. The point of concurrency of medians of a triangle is called the centroid. And then it tells us to use the concurrency of medians theorem, which we'll talk about on the next page when we turn our page. But from J to N, we want to find the whole length. So we have JQ is equal to 18. We can see that in our picture. J to Q is actually 2/3 of the line. And then QN is 1/3 of the line. So what I would do is I would divide JQ by 2. and then that gives us 9. So 9 is 1/3 of the line. And JN is the whole line. So if we have 18 plus 9, we get 27. So the whole length is 27. And if you divide 27 by 3, you get 9. So 9 plus 9 plus 9 is equal to the whole length. So this piece from J to Q is 18, and then from Q to N is 9. And you can see how that is 1/3, and this piece is 2/3. Right, and turn the page when you're ready. This is the theorem for concurrency of medians. And it's saying that the medians of a triangle, which you can see in this triangle, ABC, the medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. So you can see that from C to F, there's the point of concurrency, which is G, and that is broken into, from C to G is 2/3, and from G to F is 1/3 of that line. And that is the theorem for concurrency of medians. And you can see that with the other medians. So from B to E, and they have a concurrency at G. And from A to D with a concurrency at G. And so 2/3 of the line is from the vertex to the point of concurrency, and then the other third of the line goes to the side. All right? Let's try this. Find AD for the triangle. And you will get a decimal answer for this. So go ahead and work on that in your groups, and I will pause the video for you to work. All right, and let's have some volunteers answer that for us. For example 3, locate the centroid. And this is a story problem. It's pretty cool. An artist wants to balance a triangular piece of wood at a single point so that the triangle is parallel to the ground. Where should he balance the triangle? And then there's a definition here. A triangle is balanced at its center of gravity, which is the centroid of the triangle. So how do we find the centroid? Step 1 is to find the median, the midpoints on the triangle. So where would the midpoint be? And we could find that by finding the perpendicular bisector of each side. But for now, I'm just going to kind of guesstimate. Where would the midpoints be? And then the second step would be to draw the medians. So you might want a straight edge for this, but you're going to go from the vertex to that middle side, or the midpoint. So from the vertex to the midpoint. Vertex to the midpoint. And where they cross, that point of concurrency, that is where the centroid is. So mark the centroid. And we'll label it Q. So that's where the artist would balance the triangle. Pretty cool. For example 4, we're going to locate the orthocenter. The orthocenter is the point of concurrency of the altitudes of a triangle. Remember, the altitudes are 90 degrees to the base, to the side of the triangle, and to the opposite vertex. So we can see in these three triangles, we have 90 degrees, and it is 90 degrees to the side of the triangle and the opposite vertex. The question that they're asking is, how does the type of triangle, whether it be obtuse, acute, or right, relate to the location of its orthocenter? All right, so on the first triangle, I want us to have a conversation about this. What would the first triangle be? Would it be obtuse, acute, or right? And then I want you to write your answers. And the second one would be what? All of the angles are less than 90, but in the obtuse one, it was 110 degrees. Right, so this angle right here makes it obtuse. All of the other ones are less than 90. So it is acute, which means the last one is what? Good, it's right because it has a 90-degree angle. And how does that affect the orthocenter? For the obtuse one, where's the orthocenter? That orange dot. The orthocenter is right here, so it's outside of the triangle. And for the acute, this is the orthocenter, where all the altitudes are coming together at their point of concurrency. And that's right, inside. And in a right triangle, where is the orthocenter? It's at the vertex where the right angle is. At the vertex of the right angle. And that concludes our notes on medians and altitudes.